I'm 37 years old, and a couple of years ago, months ago, I entered a particular stage in my life. I don't know if you've experienced the same thing, but I entered a midlife crisis. So, and by entering midlife crisis, midlife crisis is that weird phase where people start to buy sports cars and use them to stand in traffic jams, or try to get the hair done in new and exciting ways, or do extreme sports just to go after the youth again. And I have to admit I did something similar. So I also tried to feel young again and fresh again, and try to mimic myself in the early 20s. So I started using React. Yeah, right? Not only that, I started dropping semicolons. Manually. No, seriously, I go over every file that I went and kill semicolons, and it gives me so much joy. So of course we have stuff like ESLint running in our code base, and ESLint tells me, oh, you have to put the semicolon in there. But there's one folder in our code base nobody knows about. No semicolons there. So there's another thing that I started using, and you might have heard of it, and it's the title of this talk. So I started using TypeScript because it was a thing 1 year ago. It was like, I guess 2019 is the year of TypeScript, if you will. And it took me a while to cross the boundary of starting to use TypeScript and starting working with TypeScript. I never felt too comfortable using TypeScript, and that changed a lot in the last year. Why didn't I feel comfortable using TypeScript? So it has to do with my free encounters with TypeScript. The first one happened at a setup similar like that at a meetup at the Technologieblauschel in Linz back then in November 2012. So 1 month after TypeScript was released, I got an introduction at a meetup about TypeScript. And people totally tried to sell me TypeScript. I started at an agency. It was the first time that I got actually paid for writing JavaScript code. So I was really excited, and I thought web development is the thing, which I still think it is. But people tried to sell me TypeScript with the words, it's just like Java, but in the browser. So this was my very first encounter with TypeScript. And I found this horrendously stupid. No, seriously, it came from people who bashed JavaScript a lot, and there's one thing that I don't like, which is bashing programming languages, because it's a dumb thing to do. Programming languages help you creating stuff, So why bash something that people can work with? Bash Nazis, much more sensible, much more reasonable. So this was my first encounter, and people told me, I can use all the design patterns from the Gang of Four finally in JavaScript, and I was like, yeah, if you think so. My second encounter was with Angular. Angular back then, Angular 2, it was called, the RC candidate, which introduced TypeScript to a really broad audience. And yeah, it didn't stick with me as well, because I tried it out. I tried to use Angular, I tried to use TypeScript, and I did my first fetch request to a backend URL, and TypeScript told me, you have to tell me what you expect from that fetch request. You have to give me the type of the data you expect here. And I was like, how should I know? I didn't console log it. So I did TypeScript as well, along with Angular, unfortunately for a time. So I started using Angular again recently and writing a lot of TypeScript. But this was the second introduction that I got. Use all those classes, use all those decorators, and please tell me the data you expect to get. Didn't stick with me as well. So that leads me to my third encounter with TypeScript. And my third encounter with TypeScript was last year during my paternity leave. I was 3 months at home with my son. And my son was a year old at the time. And whenever we were tired or tried to kill time, we watched YouTube videos. We watched YouTube videos of programming languages. I learned a lot. So did my son, obviously. I learned Rust, I learned Kotlin, I learned C++ 2017, which is, they tell me it's easier I'm not so sure about it. But there's one particular series of videos we got really stuck with, which was watching this guy, Anders Hallsberg, talking about TypeScript. And when you listen to Anders talking about TypeScript, it becomes radically different to what other people talk about TypeScript. So there was those Java devs who told me, you know Java in the browser. And I was like, yeah. And there was those Angular devs, or Angular itself, who told me, please type the stuff of your fetch request. I probably did it totally wrong, but this was what I got out from that. And talking about Anders, he totally, seeing Anders talking about it, it was totally different. And I guess it was totally different because you have to understand where Anders comes from. Who in here knows Anders Hallsberg? Okay, cool, a lot of people. So Anders created those programming languages. Turbo Pascal. Who in here has heard of Turbo Pascal? Yes, yes. Who has used Turbo Pascal? Yeah, very cool. So that stuff is still taught at universities. And Turbo Pascal was brilliant in some way, because remember, or try to imagine the early 80s. And when you wrote Pascal, it was like, yeah, I wrote my code, exit the editor, switch in floppy disk 1 for the compiler, compile your Pascal code, compile it another time because you need all the symbols from the first compile to be usable in the second compile, exit the floppy disk, enter another floppy disk, the linker, link it, get an error, exit the linker disk, enter your editor disk again. Half an hour later, you can finally fix your bug. This was Pascal back then. Turbo Pascal was a very reduced Pascal set. The compiler was so fast and so tiny that it was able to run in memory. So what Anders brought to the table was an integrated development environment, an editor and compiler and a linker that could run in memory, and you had all those compile steps within seconds. So it wasn't that he created a creative programming language or a programming language that changed everything. He created an integrated development environment, and he made Pascal usable for the masses. And this is why it got so popular to this day, because you know all those university books are written for Turbo Pascal. And the same with Delphi. So Delphi is Object Pascal. It's a derivative of Pascal, and it's not one of those the most clever programming languages either, but it had this editor. You could drag and drop elements on a canvas and create a Windows UI. Who here has created Windows UIs in C? How did you like it? Painful, absolutely. It was super painful. And this was just drag and drop and creating a couple of functions. So it was also about the tooling. And if you think about C#, you know, it was laughed upon, like, you know, C# it's just the Microsoft Java, which it was, of course. But it came with a connection to a database. It came with editors for an UI, and you were really, really fast in creating actual output. And this was always Anders' goals with programming languages. Same with TypeScript. So the TypeScript project started out in 2011 as Strada. And if you look at the original design document from almost 9 years ago, there's a couple of things they highlight and they really think about and want to focus on. And two of those highlights I want to highlight. One is do language innovation only where it's critical to Strada's goals, or TypeScript. Strada became TypeScript. So it's not about creating a new language, it's about creating a language that's usable and fun to use, and only where it's really, really necessary, do language innovation. And the other one is please support excellent tooling. So it was also all about the tooling. Talking about language innovation, so what do you think is this? It looks like, you know, I have a couple of classes there with functions. That was around 2000, 2008. You have some types there. You have a colon with a return type from a function. You have a type that encapsulates two points here. So before I ask the question, what do you think that is? Who in here knows about the basic type annotations in TypeScript? Okay, a couple, very good. This here is a document from 2001, which was the ECMAScript 4 standard. So it looks a lot like TypeScript, but it was already imagined by other people who tried to bring JavaScript to that level. So it's not that the TypeScript team created something entirely new. They tried to look as much as possible to the original documents, which is pretty great, I think. The original ECMAScript 4 documents also proposed some stuff like union types, which became a major concept in TypeScript. And this is what, so just look at the amount of code, but this is a validate function, and to try to get rid of that validate function just by adding a couple of types up there. And this was a lot of inspiration for TypeScript. So it's not like, hey, create Java for the browser. No, it was just not about that. It was about make JavaScript usable at scale by providing excellent tooling and try to stick as much as possible to the ECMAScript standard. And this is what it is still today. So you don't get any new language features in TypeScript, especially not now since we have a good process with TC39. TypeScript is the best preview that you can get for new JavaScript language features. You've seen the release of TypeScript 3.7 just recently, which brought nullish correlation, and it's just a tongue twister, nullish correlation. Yeah, do I say it right? We have a native speaker up there? Nullish correlation is the... Okay, probably. or the question mark operator. Say it again? The Elvis operator, yeah, because it's like, yeah, very good. Something that TypeScript is now gets a lot of attention for that, and people are very joyous about those new features and say, okay, they're cool TypeScript, but this is coming to browsers eventually. So we're getting all those features in browsers at some day. You just get the best preview because every new language feature is a stage 3 proposal in JavaScript, and you can try it out first in TypeScript or stable in TypeScript. And coming from this side, you get a totally different feeling about TypeScript altogether. So suddenly I don't see it as a language anymore, but as some sort of tooling, very, very not obtrusive, you know, the stuff that really goes deep, tooling that is written within my JavaScript code, but still tooling instead of an entire programming language. And I really, really want to stretch out this video. Oh shit. Recording still works? Yeah, absolutely. So I really want to give some focus on that video, which is Anders Halsberg and Lars Bach talking about, just keep it like that, talking about the recent creations. So one is TypeScript and the other one is Dart. So Lars Bach is also a Danish guy who created Dart, and they are talking about how to create programming languages that should eventually compile to JavaScript. And Lars is talking about all those features that he wanted to include in the programming languages, which he thought is useful in a modern day programming language. And Anders is only talking about tooling, only talking about following the ECMAScript standard, only talking about making that thing work for day-to-day JavaScript devs. And this is what I found really, really interesting. So before I go into the examples, I want to stretch the fact that TypeScript is JavaScript. It's a little bit more, of course, but you know the thing that TypeScript is a superset of JavaScript? That's true. There's a couple of weird looking features like abstract classes, enums, decorators, stuff like that, that they included at some point because, you know, there was a demand for that. But that's just a side effect. In truth, it's just JavaScript as it's going to be with types. And now I do some live coding, so I might fuck this up. And with that mindset, I played a lot with TypeScript in the past, and I found some things that I kind of found odd about it, which I thought, okay, how does this came to be? And by thinking about it, I realized, hey, it's really, really strongly connected to JavaScript. So this is a function. You've all seen a function like that. So I didn't just want to write foo. That's why I called it I have no return value, because this function has no return value. It's just a function that you call, like I have no return value. You add, let's say a number. It allows anything. And you're good at that. So now I have one question. This function has no return value. What if I assign an imaginary return value to, let's say, a constant like const x? It compiles. And this is the first thing that I kind of found out, because, you know, in theory, if you look at the function, this is the automatic type inference by TypeScript. It allows any parameter and returns void. You know, void is like nothing. It has no return value. So let's make it let's make it visible, this is void, but I can still return it. This is not the Java I know or the C# I know, you know, this is something that kind of out in Java and C# this would be a compile error. So what's happening there? Let's look at X. So X is void. Oh, that's cool. So void apparently is a valid return type, and this function returns void. In other languages, this is nothing, not a return value. In TypeScript, it's a proper return value. Anybody an idea what this would be in JavaScript? Very good, undefined. So we can try it out, but let's say you just believe me because I don't know the shortcut to make the console open. Yeah, so it's undefined. X is undefined. If I console log X, it will output undefined, which is a very fun thing in JavaScript because JavaScript functions have a return value. Each one of them has a return value. Either it's something that you actually return, but if you drop the return value, it returns undefined. Very cool. So void is not only this type of bottom type where, you know, if you don't have anything, just use void, and this is something that never should return anything. Void is very similar to undefined. Up to a point, let's see, nope, that's a different shortcut. Yes, this is another function. I just declared that function. I take no parameters. So if you use declare, you can have a function without a body, and TypeScript just assumes this function is there. I take no parameters where I use void as an input type. So the cool thing is I can call I take no parameters with nothing, which is okay. If I put in 1, it gives me an error because 1 is not possible. It's of type number, it's not of type void. But you might guess it, I can put in undefined, and it just compiles as it should. So undefined is a total replacement for void, which brought me a little bit about the weird dynamic of void and undefined. Why there are two types who just do the same? Because, you know, I can have a value that is of type undefined, and it just can be undefined. So I can't assign anything else to it. Undefined is a proper type in TypeScript. Yes? Can you pass X? I can pass X, of course. X is undefined. So why does this idea of undefined and void exist both in TypeScript? Turns out void also exists in JavaScript. Who has heard of void in JavaScript? Just a couple, very good. So void is a keyword in JavaScript. Probably you've done something like that in your parts. So those people who know about void in JavaScript, it's just like, okay, href is JavaScript.void, :void. You've done something like that probably at some point. You copy and pasted that back in your day. Don't do that. First of all, this is not how you should use an A element. But this is, you know, a call to the browser. No, I execute JavaScript and I do just nothing. And you can do some weird JavaScript stuff afterwards with that. The thing is, void exists as a keyword in JavaScript, and it's some sort of safeguard to make sure that you never get a return value. So I can't use I take no parameters with 2, but I can use it with void 2. So void in front of 2, anything that happens here, no matter what happens here, this is a safeguard that tells me, you know, I just return undefined. You can do funny stuff with that, like I have some weird condition. Yeah, but it's a good weird condition that doesn't give me browser errors. Let's do that. If true, I can return and execute a function like I have no return value. If I don't expect this function to ever return a value, but I want to break out of that condition and execute the function in the same go. So instead of doing that, I could also do something like that, you know? You know, this is, sorry. This is totally valid, all right? What if this changes at some point? I have no return value. Suddenly, if I call few and I come into this condition, I get a value, even if I don't want to. This is why I can have a security guard like void, and you can execute this function, and you always get undefined in return. So it always returns with void. Of course, if you go all in TypeScript, TypeScript will tell you. But if you're just writing JavaScript, this is some sort of safeguard mechanism that you can use to make sure that at this point you don't get a return value, because it might fuck up your code later on. Alrighty, so void. Void has, I can do a whole talk about void, which is great. Yes, already. There you go. The recording still works, hopefully. Otherwise, I have to do it again. I'm so sorry. Alrighty, void has a couple of other very funny features. So let's go to this. You have seen functions like that. This is just a do something function, and it takes a callback. You know, I can execute a callback. In that case, C is undefined, but it's also, you know, something like that. This callback is interesting because it takes no parameters and it returns void. So this is what we expect. I can do something like do something, and here's a function like that. Hello, works wonderful. And as it should, because this function doesn't return anything. It also has no parameters. Very good. What if I, okay, this is that. What if I have a callback like this? This is a number callback, and it returns 2. What do you think? I call do something and pass this number callback in there. Does it work? Who is for it does work? Who says it doesn't work? Who is totally unsure what I'm doing here? So I pass a number callback, and it compiles, which is kind of odd. You know, this is a totally different signature like this one, and it also returns something which I don't want here. How does this work? And this is a very special case of TypeScript, and this also leads me to how close TypeScript is to JavaScript. This is allowed because something like that happens in the wild. So even if this callback annotation doesn't need a return value, you are allowed to pass anything that at least has the same parameter signature to it, because you are checking if you have a number or not at this very position here, callback. So even if I pass a number callback that returns a number, if I assign it to I, from this position on, I is undefined for the compiler. So I can't do something like console log I plus 1, because I is not a number, I is undefined. I can't add 1 to it. And this is one way of TypeScript to tell you that, to try to be compatible with the JavaScript ecosystem, because this is something that happens in JavaScript all the time. If I want to make sure that I can't pass this number callback, I have to go to, I'm so sorry, predefined snippets. If I want to make sure that I can't pass this number callback, I would have to change this type to undefined. And suddenly, I can't substitute undefined for number. And this is the concept which is called substitutability, which is also a tongue twister, which is a concept for TypeScript to say you're allowed to pass functions with different signatures as long as it doesn't change the semantics where you use it. So the semantics here are still the same, and void is allowed to be substituted. Undefined is not allowed to be substituted. All right, another thing about substitutability, because you have that also all the time, I guess it's example 5. So this is a fetch result call. Again, it's not supposed to do that. So this is a fetch result call. I'm super sorry about all the technical stuff. It also takes a callback, but this callback takes a status code, let's do it as C, which is a number, and it passes some results, which is an array of numbers, and it returns void. Very good. So in here, let's think of fetching some data and then calling the callback, and the fetch was successful. That's why I passed 200 a status code, and I passed a results array. Very good. So I have now a handler that I can pass to fetch results, which just takes a status code. So what do you think? If I call fetch results with this handler, the handler function, who thinks it does work? Who thinks it doesn't work? Who is totally unsure of what I'm doing right now? I'm so sorry for that. Please come talk to me afterwards. So if I pass the handler, it still works, even though this signature is totally different from this signature. This is also part of substitutability, and it comes from stuff like, writing an express server where you can have stuff like request, response, and the next middleware. What if you just need response? Your ESLint configuration is going to complain because you have unused parameters. And since this handler function doesn't need the parameters, and it's okay in JavaScript to call a function with as many parameters that I like, not in that case because it doesn't comply with that one. But in JavaScript, that's totally okay. This function just takes the first one. I can use this function, even though it has a different type signature, as a callback over there. This is also called substitutability. Quick look at the time, 5 minutes. So this was example 1 of 3. There's a lot of other things that I can show you. Let's do it like that. I give you a quick look out because I can do a whole talk about what I can also do a whole talk about the constructor interface pattern, where I realized if you define a class in TypeScript, like let's say some filter item that has a filter function and a constructor and stuff like that, you don't have one type, but you have 2 types. You have the type of the constructor function and the type of the object that is returned by the constructor function. And this mirrors also JavaScript behavior. Like, if you have a JavaScript class, you can construct it in something like that, having a constructor function and having a prototype with functions to it. And this is all merged together in a class in JavaScript right now. But this is the same thing. It's just a different syntax for it. And if you look at that, you see, okay, this is a type because this is a function, and this is a type because this is the prototype of that. It even has type in its name. So you need 2 types to properly define an interface for a class. 2 types because JavaScript has 2 types. And also a quick lookout because I'm 5 minutes in late already. That's substitutability. That's symbols. So symbols is a really cool thing in JavaScript and TypeScript because symbols is the only way to create, for example, where are we? Runtime enums. This, you can't see that. File. Faxing code. Resend. Okay, I'm super sorry, it's going to the playground. Here it is again. You can see that. This here are unique symbols, which I combine in one color constant, and with that I get some similar behavior to enums in runtime. So I can't use stuff like color black in there if I don't have it defined in this color enum. This is just JavaScript. This is not TypeScript, and it has some wonderful implications in TypeScript because you get this a unique keyword. It's a unique symbol, which means it's just totally again. Which is a feature that is coming to all other types in TypeScript at one point, which means that I can't confuse this color red for another color red, for example. There's a lot of stuff to look up. I'm super sorry that I use so much time on just discussing void. Those are the resources. You get all those slides again. For me, this means TypeScript is JavaScript, which also leads me to the way I work with TypeScript. I write modern-day JavaScript and just annotate where I think it's absolutely necessary. TypeScript does a lot of work for you to figure out which types you meant to use just by looking at return values or input values or how you use those values. It thinks a lot for you, and I think a tool, I'm in my midlife crisis, a tool that helps me understand my JavaScript code. I really appreciate that. So I just annotate where necessary. I try to avoid all non-TC39 features. I don't use decorators, I don't use abstract classes, I don't use enums, because I'm not sure if they ever will reach JavaScript. I just use what JavaScript is going to get at some point. And this is, this is something like, is it going to be in JavaScript at one point, or isn't it? Thinking about decorators. But this is a very safe way for me to use TypeScript. And And please don't use features that mix types and code generation. So for everything that you write in TypeScript, you generate some code out of it. Thing is, if you just use type annotations, these are all going to get erased. There are just some stuff like abstract classes or enums that are kind of a mixed bag. They are used as a type when you write TypeScript, but they produce actual code at runtime. So I don't like that very, very much. Yeah, so that was about it. That was a quick introduction on Void. I'm Stefan Baumgartner. I'm that parrot on Twitter, the most gruesome Twitter handle that you can imagine. I organize ScriptConf and Dev1. I podcast at Working Draft, and I write a ton about TypeScript at Fatblog. Thank you very much for having me. I'm open to all your questions.